Yes, yes, yes. Now listen, I will keep the call so that I can get the thing that whether it is a call voice or video voice. Okay.
Okay,
I will
fine.
message
Yeah.
you immediately.
Yeah,
Yeah,
okay,
yeah.
fine. Yeah.
Yeah. Bye.
Bye. Chitra, please check if my voice is clear. Okay, is it clear, Chitra? Perfect. Okay, fine. Let's continue. So guys, we have completed the entire regular languages part, except two models. Okay, there are two models which are not very important. So I will cover them, but I will cover them after I complete the entire important topic. So two models are, one is how many DFAs are possible, how many NFAs are possible, right? This is one question. It is not very important. Actually, this question comes under the topic of permutations and combinations. It is not a TOC question. Okay, but still we will solve it. Now that you know permutations and combinations, we will do a lot of questions on this model. Okay. Okay, and then the other model which we have already done is how many strings are possible with let us say 3 zeros, 3 1s. This is a Mississippi problem, right? 6 factorial by 3 factorial to 3 factorial. And then they will ask you how many prefixes are possible. This is also a counting problem. So all these problems are not TOC problems. These are all counting problems. So what I will do is in the permutations and combinations lecture, I will do this. I'll do these questions because they are not TOC questions. Okay. And then one model that we have to cover is divisibility. Okay. So let us say divisible by 8. Okay. So this model has not come in GATE yet. They might ask you this model, but till now no questions are there on GATE, so I'm not doing it now, but I will do it later. Okay. So we have counting problems and then we have one more problem in regular languages. With that, regular languages will be over. But without doing these, I will start with the PYQs. Okay. So from Tuesday onwards, we are going to have marathon of PYQs on regular languages. Okay, and that will be extra class. Okay, so we can have the marathon from 10 p.m. till 12 a.m. Okay, 10 p.m. till 12 a.m. we'll have the marathon, and then from 6 p.m. to 8 p.m. we will be doing context-free languages, and from 8 p.m. till 10 p.m. we will be doing DBMS, and from 10 p.m. till 12 a.m. we will be doing PYQs ka marathon on TOC. PYQs marathon on TOC. Okay. So if you don't want to attend it, you don't have to attend it. Maybe if you want to see the recorded lectures, you can see the recorded lectures later. Okay. That's about it. Okay. I'm going to see your messages in Telegram channel. Okay. Open the Telegram channel, everyone. Okay. Yeah. Okay. Okay. Now let us see context-free languages. And in context-free languages, we are going to see first push-down automata. Okay. So let us start context-free languages. Context-free languages. Context-free languages. In this, we are going to discuss about push-down automata. Push-down automata. And then we are going to discuss about context-free grammars. Right. Actually, there are two subparts of context-free languages. Okay. In context-free languages, there are two subparts. One is called deterministic context-free languages, and the other one is context-free languages. Okay. So we will do both of them. In GATE, there are questions where they ask whether the given language is deterministic context-free language or is it a context-free language. Okay. In the exam, these questions are given. So we'll focus on that. Okay. Now, what is pushdown automata? I will take a finite automata and I will add a stack. Okay. So where did this stack come from? Okay. So now the question is, okay. So let's take a 2 minutes ka break. Okay. I will have something. I'll have some breakfast and connect. Within 2 minutes, I will connect. Okay. Let's take 2 minutes ka break. Okay. I'll have some breakfast. Okay. I'm just hungry and okay. Once I have food, I'll be very active. Okay. Just give me 2 minutes of break. Okay. I'll have some dosa or idli. Okay. Okay. Breakfast is not ready. So let me have some chocolate. Okay. I like Mars chocolate. This one. Mars. Mars is very good. Okay, we'll start. Okay. So let's look at the stack. Origin of stack. Let's look at the origin of stack. Okay. So where did this stack come from? Initially, who invented this stack? There is no name given to anyone. This data structure, in one of the textbooks, there is a very good book called Algorithms to Live By. It doesn't cover entire algorithms, but they will tell you which algorithms are in the practical. That is a very good book. Okay. It is not about core man or actual algorithms, but that's a good book. I will teach you that book when I teach algorithms. Now the question is, who invented stack? Okay. Who invented stack? So earlier there used to be restaurants, and you know buffet, right? Buffet. Buffet means you can have unlimited food. Okay. So then what they did was they used to put the plates one on top of the other, and people used to take the plates from the top. Now the problem was they wanted these plates to be sanitized, right? So they have invented a machine. They have invented a machine which produces steam. Which produces steam. Steam, you know, right? That boiled water ka steam. So that all the plates will be sanitized. If there are any germs, they will die. So what they did was they have kept a spring in the bottom. Okay. And on top of that string, they have arranged the plates like this. They have arranged the plates like this. These are all plates on top of the string. These are all plates on top of the string. Okay. Now the beauty of this machine is, this is physics actually. When someone takes out a plate, automatically this spring will have less weight on top of it, and it will push the next plate onto the top. Now if the two plates are removed, it will push the plates up and you will get the third plate. So this is the origin of stack. That is where stacks were invented. Okay. And then we started applying them for various data structure problems. Stack is a very important data structure. We are going to cover at least 10 hours of stack problems. Okay. Or even more than that. I think I will be covering stack problems for 20 hours. Okay. So this is about stack, guys, right? Now, what is the relationship between push down automata and stack? If I take a finite automata and if I add a stack to this, if I take a finite automata and if I add a stack to it, okay, then that will become push down automata, right? So one thing that you have to observe in normal stack and push down automata stack is, if you look at normal stack, let us say there are numbers 1, 2, 3, 4, 5, right? So if I do pop, 5 will come out. If I do push 6, 6 will be pushed. This is how normal stack works, right? And in the normal stack, there is something called as peak. Peak, right? Peak means don't remove anything from the stack. Just tell me what the top of the stack is. Now it will not remove anything from the stack. It will just say peak is 6, which means 6 is in the top of the stack. 6 is in the top of the stack. Now this is how general data structure stack looks like. General data structure stack looks like. Okay. Now coming to stack in push down automata, right? What happens is, let us say bottom of the stack is always going to be Z0. Remember this point. Okay. Vasudha, write this point. Bottom of the stack is always Z naught. Okay. Now let us say there is A, there is B, there is C, there is D. Now if I want to find out what is on top of this stack, right? In pushdown automata, this stack, if I ask peak, tell me what is on top of this stack, then pushdown automata will delete this element, bring it outside, and it will say that, hey, top of this stack is D, peak is D, right? Now it is your responsibility to place it back if you want, or leave it as it is. Why is this method used in stack in pushdown automata? Is because, why is this method used is the question. Why is this method used is the question. Because in pushdown automata, there will be only push. There will not be pops. Then how can we do the pop? Whenever you ask for the top of the stack, the item is already getting popped. If you don't put it back, that is as good as popping, right? Vazza, please write all these points, okay? Whatever I told you, please write all these points. So you know how to push, that is a normal push, but you don't know how to pop. How does pop happen? You are going to remove the top of the stack, okay? And that is going to come out. And if you don't place it back, that is acting as a pop. So indirectly, we are implementing pop also on the stack. Pop also on the stack. Right, right. So when I say pushdown automata is a finite automata plus stack, you may get a doubt whether this finite automata is DFA or not. It need not be DFA, it can be NFA also. It need not be DFA, it can be NFA also. It need not be DFA, it can be NFA also. Okay. Anyway, that is not an important thing. Okay. Now let's try for a language. Let's try to do a pushdown automata. Let's try to do a pushdown automata for the language a power n, b power n such that n is greater than or equal to 1. A power n, b power n such that n is greater than or equal to 1. Can you draw the pushdown automata and post it in the group? Can you draw the pushdown automata and post it in the group? Can anyone do that? Try this, guys. This is not a finite language, regular language, right? But this is DCFL. If it is DCFL, it is CFL also. If it is CFL, it is CSL also. If it is CSL, it is recursive language also. If it is recursive, it is regular recursive enumerable also, right? Right? Try this. Okay, let me explain you one question. Okay, let me explain you one question. So initially you will be in state Q naught. Okay, so let's say the string is A, B, B, B. Or let's take two, A, B, B. Always bottom of the stack is Z naught. Always bottom of the stack is Z naught. Okay. So initially I will be in Q naught, and if I see a, top of the stack is Z naught, right? Now what happened, guys? So in the input, I'm seeing a and top of the stack is Z0. Whenever I say top of the stack is Z0, actually Z0 is coming outside. Now you have to place that Z0 back if you want, okay? We want it. We want to place the Z0 back because that represents the bottom of the stack. Now what I will do is I will put back Z0 and I will put A on top of it. How do you understand it? You are going to put all these things. See, one pushing, you can do any number of pushings. Popping, you can do only one popping. Okay. So what does this mean? On seeing a, if the stack is empty, I'm going to push Z0 because it came out. I'm going to put Z0, and on the top of A, I'm going to put on the top of Z0, I'm going to put A, and I'm going to move to the next state. I mean, not next state, next symbol. Okay. Now what happens? Top of the stack is A and input is also A. I will push all the A's onto the stack so that I can compare them with B's. So if the top of the stack is A, if the top of the stack is A, if the top of the stack is A and sorry, if the input is A and top of the stack is A, which means this A has come out, right? Now we have to put this A back and the new A. So put the A back and then on top of it you put a A. So what happens because of this? So we are going to get all the A's on top of the stack. All the A's on top of the stack, right? Now whenever B comes, I am going to pop one A. Whenever B comes, I am going to pop one A. Whenever B comes, I'm going to pop one A, right? Whenever B comes, I'm going to pop one A, right? So one thing that you have to remember here is we have to go to a different state. You cannot pop in the same state. The reason is you have to remember that you have started seeing B's and after seeing B's, A's are not allowed. If you do popping here only, then what happens is A may come, then B may come, then A may come. We don't want that, okay? That is why on seeing a B, okay, on seeing a B in the input, if the top of the stack is A, if the top of the stack is A, which means this A has come out, I will not put back A, right? I will put epsilon. Now what is the meaning of it? We have popped A. The meaning of it is we have popped A. We have popped A. The meaning of this is we have popped A, right? Now you will be in a new state. Let in the input any number of B's come. If A is on top of the stack, it will come out, right? A is on top of the stack, just replace with epsilon, right? Right? Now, if all the A's and B's are over, at the end there will be epsilon. At the end there will be epsilon, right? So you cannot accept here. You cannot make this the final state, right? Right? Why you cannot make this the final state? Because even if there is one match between A and B, the entire strings are going to be accepted. Therefore, you create a new state and make sure that after AABB, see, there may be inputs like this, AABBA. You have seen these four and you have accepted it, but this string is not in the language. Therefore, see that you go till the ending. Okay, see that you go till the ending, that you see epsilon, at the ending that you see epsilon, At the ending that you see epsilon. Now what will be the top of the stack? Top of the stack is Z0, which means input is over and also all the A's are over. Then only you are going to accept it. Then only you are going to accept it, right? So I do one thing. I will give you 3 minutes of time. Okay. Without looking at the board, you solve this question on your paper. Then you will understand it. Okay. On your book and paper, I'll give you 3 minutes. Solve this. Okay. Okay. Then I will tell you more about it. Okay. I don't want to confuse you by everything, doing everything now. First learn this. Okay. First try to do this without seeing the board. Okay. Without seeing the board, first try to do this. Okay. In your book. Okay. Fine. Now the question is this finite automata a DFA? See, what are the input symbols A and B, right? So here we are told for Q naught what happens on A and what happens on B for every input symbol. See, this transition is different from this transition. It is not just seeing a, it is seeing a and Z naught on top of the stack. It is seeing a and A is on top of the stack, right? It is seeing a B and A is on top of the stack. Now if you observe it here, no move is mentioned for A. Let me write the states Q0, Q1, Q2. Okay. So for Q1, you didn't define anything for A, right? So whatever are not defined, they are all called as dead configurations. Okay. Whatever are not done, they are all called as dead configurations. Okay. Now why are dead configurations important? Because we are going to reject some of the strings, right? So whenever you come across dead configuration, you can say that this string is not, you can say that this string is not in the language. This string is not in the language. I'll give you an example, okay? Let us say the input is BA, okay? The input is BA. Bottom of the stack is going to be Z0. Now initially you will be in the state Q0 and you are seeing a B. You are seeing a B, right? So Q0 can see a B provided that top of the stack is A. But here top of the stack is Z, right? Therefore, this is a dead configuration. This is a dead configuration and BA is rejected. Whenever you hit a dead configuration, whenever you hit the wall, that string is not accepted. Why is this not accepted? Because we want the strings A power n, B power n, but here it is starting with B. That is why this is not accepted, right? Now let us say it is starting with A only, but there is only one B. But there is only one B. Now what kind of dead configuration do we hit? Okay. So A, B, epsilon. Okay. A, B, epsilon. A, B, epsilon. A, B, epsilon. Now you will be in the state Q naught, right? Q naught on seeing A and top of the stack is Z naught. It is just going to push the A. It is just going to push the A and B in Q naught only. And Q naught on seeing A in the input and A on top of the stack, it is going to push A and we are going to the same state Q naught. When Q naught sees a B and A is on top of the stack, A has come out, right? And we are not going to push it back. So I am going to Q1, right? Now, what is the configuration for Q1? The configuration that Q1 is seeing is, it is seeing epsilon. It is seeing epsilon. See, in this, you can put back Z0 or remove Z0, okay? So, it is seeing epsilon. Q1 is seeing epsilon, but top of the stack is A, which means this is the configuration it is looking at. And for this configuration, pushdown automata is not for this configuration, pushdown automata తీసేసా బాక్స్లో ఇవాళ వెళ్ళి తీసుకురా మళ్ళీ okay. So for this configuration, it is not defined. So if there are unequal number of A's and B's, it will not be defined, right? Now let's take one more string and see how dead configuration works. Okay. Now let us see the case where B's are more than A's. Okay. Let us see the case where B's are more than A's. So A, B, B, B. Okay. So let's start the stack. initially on top of the stack there is going to be Z naught. So I will be in state Q naught. On seeing A, I will go to state Q naught only, and I will add A, push A. And again, if I see A, I will be in Q naught only, and I will push A. Now, if I see a B, I will go to Q1, and top of the stack is A, I will pop A. Now, on seeing a B, I will be in Q1. Now, on seeing B, I will be in Q1. Now, on seeing a B, I will be in Q1, and there is A on top of the stack, pop off. Now, on seeing a B, Q naught on seeing a B is seeing Z naught. Okay, see this. Sorry, Q1. Q1 on seeing a B, it is not seeing a, it is seeing Z, which means there are extra B's compared to A's. Therefore, it will go to dead configuration and it will not accept it. It will not accept it. Right? So, one question I am going to take in detail. For the remaining questions, you should be able to do everything. Okay? Okay. Okay. Now, let's see a different case. Okay? Let's see a different case where, let me use a different stack. Okay? Stack is Z naught. Let us say A's and let us say A's and B's are equal, but after a B's there is a. Now what happens in this case? After a B there is a. Now what happens in this case? You will again hit the dead configuration. Initially you will be in state Q naught. On seeing a, you are going to push A and you will be in state Q naught. And on seeing a in Q naught, you are going to push A and you are going to be in Q naught. Now Q naught on seeing a B, it is going to pop a and it will go to Q1. Now Q1 on seeing a B, it will pop a and it will go to Q1. Now what is the configuration? We are in state Q1 and the configuration is we are seeing A and Z naught is on top of the stack. Z naught is on top of the stack, right? Right? So in Q1, we are in Q1. In Q1, we are seeing A and Z naught on top of the stack. That is not defined, right? So this will hit the dead configuration. So these are the things you should understand about pushdown automata. And I'm not going to do this for every question. If I do this for every question, finding out all the dead configurations, we will not be able to cover the syllabus. Okay. So you should be able to do this from now on. Okay. Now let me give you a question. Okay. Let me give you a question. Okay. So the question is a power n, b power n, c power m such that n comma m greater than or equal to 1. I expect you to do this. Okay. I expect you to do this. Write it in the Telegram channel, whatever answer you get. Okay. Do it in your book and show me the diagram. Take time, okay? See, while practicing, just go slowly. We need perfection. But in exam, you are going to go very fast, okay? In exam, you are going to go very fast. Try this one, everyone. Wow, Kirutika, very good. Uh, Very good, Kirutika. Anyone else, guys? Are you trying? See, you have to try. If you don't try, you will not get it. Don't be lazy. Do write something on the paper, try it out. Even if it is wrong, I'm not going to scold you, right? I will explain you where you have gone wrong. I'm not going to scold you. Take time, okay? Take time, okay? Yeah, boiled eggs. Hmm. I every day for lunch I eat outside only. So every day lunch I eat. So, okay, take time. There is no urgency. I just want correct answer. Okay, there is no urgency. I just want correct answer for this. Okay. See, when we are solving, I'll give you a lot of time. It is not exam, right? So let's do this. Now you have to compare A's and B's. Both of them should be equal. And there can be any number of C's. There is no restriction on C's, but only restriction is there should be at least one C, right? Because n comma m are greater than or equal to 1. What is the smallest string you get? A, B, C, right? So let's draw this. Initially, you will be in state Q naught and you may get a in the input and top of the stack is Z naught. You are going to push A and you may get a and top of the stack is A. You may push A. You may push A. You may push A. Now once you get a B and if top of the stack is A, pop it off. And any number of B's you get, if top of the stack is A, keep popping off. Now let us assume A's and B's are over and they are matching. Then you see a C, you don't have to do anything with C. You can push it or you can leave it, anything, okay? Now you see a C and top of the stack should be Z naught. See, when the A's and B's are matching, then top of the stack will become Z naught. If A's and B's are matching, then top of the stack will become Z naught. Okay. Now, when you see a C, stack should be empty. It should be Z naught. Now you can leave it as Z naught or you can pop it off, not a problem. Now there can be any number of C's. Let any number of C's come. Top of the stack is going to be Z naught. Leave it as Z naught itself. Okay. Finally, when all these C's are over, you will get epsilon and top of the stack will be Z naught, which means A's and B's are equal and C's are over. What does this mean? A's and B's are equal and C's are over. You can leave Z0 as it is and you can finally accept it. Right, right. Don't make this one as accepting state, because there may be cases where you will get A, B, B, C and then A. So you have to check till the end, right? You have to check till you get epsilon. You have to check till you get epsilon, okay? You have to check till you get epsilon. Okay, that's it. Now I'm not going to handle all the dead configurations, you do it. What are the various dead configurations we may come across is if the string starts with B, or if the string starts with C, or there are unequal number of A's and B's, or there are unequal number of A's and B's followed by C's, or there are B's more, or there are B's more followed by a C. All these will hit the dead configuration. Okay, I'm not going to do that, you please do that. Okay, because it will take hell a lot of time if you do that for every question. Okay, now I'll give you next question, try to answer it. Okay, so a power n, b power m, c power n such that n comma m greater than or equal to 1. Okay, solve it. See, push-down automata is such a topic where you have to solve every question. I'm not going to solve all the questions, okay? I will ask you to solve. Otherwise, you will not get it, right? Later, you will get lot of doubts. Coming to finite automata, even if I solve, you will understand it. But for push-down automata, you have to solve it, okay? Very good. Who is this? Manasa Reddy. Mansa Reddy, very good. No one is able to answer this, okay? No one is able to answer it. Okay, one more guy. Who is his name? Kirutika. Acha, only girls are answering. Only girls are answering it. Kirutika. What about others, guys? Okay, so you are right. Both Kirutika and Mansa are right. Let me just do it. Okay. So what we should do is we should push them onto the stack. B's, you don't do anything. Just leave them you don't take either push or pop option. And for C's, you are going to pop yes, right? And one more guy, Pratibano. Yeah, you are right. Okay. So initially what happens, guys? Initially, let any number of A's come. You will be on top of the stack will be a push A, right? And let any number of A's come. You are going to push yes. Any number of A's come. You are going to push yes, right? Now let us say all the A's are over. Now you will get a B. When you get a B, see m comma n is greater than or equal to 1. So the minimum string is A, B, C, which means when I get a B, there will be at least one A on top of the stack. So there will be one A on top of the stack, and whatever A has, see this, let us say Z naught is on bottom of the stack. You have pushed A and A. You have pushed A and A. We have pushed A and A. Now, whenever you get a B, there will be at least one A on top of the stack. Now, don't do anything with that A. Just replace that A back. See, try to understand this. If I say A Z naught, A Z naught, this is actually a push action, right? Now, if I say something like this, A B epsilon, right? This is nothing but popping B. This is a pop action, right? Now if I say something like this, A, B, B, which means top of the stack is A, B, and again I am placing B back. Top of the stack is B, and again I am placing the B back. Top of the stack is B, and again I am placing the B back. So this means it is not push, right? And it is not pop. So when you are seeing B's, you don't pop A's because we need them for counting later. Later we have to compare them with C's. So don't pop them. Okay. Don't pop them. Okay. Now you can get any number of B's. Don't pop anything. A will be on top of the stack. Just A, let A be there. Then you will start getting C's, and what will be on top of the stack? B will not be on top of the stack. We never pushed B. Top of the stack will contain A. Why? Because when I see a B, a C, I didn't do anything for B, but I have already pushed a. There is at least one A. Therefore, when I see a C and a, I have to do the matching, right? C's have to be matched with A. Therefore, I am going to pop. Therefore, I am going to pop. Now, any number of C's may come, any number of C's may come, right? And top of the stack is A, you keep popping them. Now let us say all the C's are over, right? See what happens here. Let us say AA, BB, CC is there. Two A's are pushed, okay. And for B's we didn't do anything. And for C we are going to pop off A, and for C we are going to pop off A. Right? Now there will be epsilon. Now what does this mean? If I reach the end of the string and if the stack is empty, it means that number of A's and number of C's are equal. Okay, so adding this is very important. If I see the end of the string, if I see the end of the string, and if Z naught is on top of the stack, leave it as Z naught only, or you can remove it, not a problem. Then you are going to accept it. Then you are going to accept it. Right? I'll give you one more question, okay? Try doing this. I'll give you one more question. a power n plus m, b power m, c power n, such that m comma n greater than or equal to 1. Okay. Cool. Most of you have answered it. So whenever such a language is given, you have to break them into parts. See, you have to write it as a power n, b power m, c power m, c power n. A power m, b power m, b power m, c power n. No, no. I did wrong. A power n, a power m, b power m, c power n. Okay. Now writing like this is important. What is the mistake that students make is they will write like this. A power m, a power n, b power m, c power n, and they say that B said A said these two cannot be compared, these two cannot. So you'll do this mistake, right? So writing it properly is very important. Okay. Now what is it? N comma M greater than or equal to 1. So what is the minimal string? A B C. A B C. Right. So what is this question? Number of A's should be equal to sum of number of B set C's. Right. So if I write A power 5, B power 2, C power 3, it should be accepted. Okay. So number of A's should be equal to sum of number of B set C's. Now if I write A power 6, A power 4, B power 2, C power 2, this should get accepted because number of A's is equal to number of B's plus number of C's. Right. Right. And one more thing you should be careful is after a, C should not come. And after a B, A should not come. And after a C, A or B should not come. There are a lot of cases you need to handle. And all of these cases will be handled by the det configuration. Even you may get a case like this, A power 5, B power 1, B power C power 2. Now in this case, number of A's are not equal to number of B's plus C's. This also should go into det configuration. Or you may get A power 2, B power 3, C power 5. In this case also, number of A's is not equal to number of B's plus number of C's. All of these should go into det configuration. Right? So whenever such a question is given, try to analyze it. Don't analyze it on the pen and paper. Do it in your mind. Okay? Do it in your mind. Then after you answer the question, just see if all these strings, are getting into, just see if all these strings are getting into that configuration. Okay. So the logic is very simple. I have to compare A's and B's and then I have to compare A's and C's. So as long as I get A's, I will keep pushing A's. And whenever I see B, I'll keep popping A's. And then whenever I see C, I'll keep popping A's, right? And at the end, you should see that when the string has ended, you should get Z0 on top of the stack. Then only we'll be sure that all the A's are over and the string is over. Okay, so let's do it. So initially, A may come, Z0 will be on top of the stack, push A. This is for sure because the minimum string is ABC. So first symbol that you get is A, right? And then A's, you may get any number of A's on top of the stack. You just keep pushing. So because of these two moves, all the A's are pushed. All the A's are pushed, right? Now, if I get a B, B, right? What should I do? I should pop off A's, right? If I get a B, definitely top of the stack will be A. The reason is the minimal string is ABC, right? Now you pop off A's. Now you keep doing it. As long as I get B's, A is on top of the stack, I'll keep popping them. Then I get a C. If I get a C, it should be matched with A. See, till this part A's and B's are matched. Now you have to match A. So C, and if A is on top of the stack, pop it. A is on top of the stack, you pop it. Keep doing it. As long as you get C's, A is on top of the stack, keep popping. This is a pop move. This is a pop move, right? This is a push move. This is a pop move. This is a pop move. Whenever you see epsilon, blindly say that it is a pop move. Okay. Now what should happen at the end, guys? The entire string should be over. Okay, entire string is over. And what will be on the top of the stack? If A number of A's are equal to B's and C's, the top of the stack will be Z naught. Leave it as Z naught. Okay, and you accept it. See, this step is very important. You have to make sure that you are, when all the symbols are over, the string is also over, right? Otherwise, you will get various strings which are not in the language which will be accepted. For example, if I make this the final state, okay, there is no guarantee that C's and A's are equal, right? So you cannot make it the final state. You have to see that C's and A's are equal. You have to see that C's and A's are equal. Okay. Okay. I'll give you one more question. Try this. A power n, B power m plus n, C power C power m such that n comma m greater than or equal to 1. Try this one, everyone. Try this one. Very good. Some of you are able to answer this, okay? Some of you are able to answer this. Let me answer it, okay? So, see, it all depends on how you write it. If I write like this, a power n, b power n, b power m, c power m, then I can compare a's and b's and then compare b's and c's. But if you write like this, a power, let us say, a power n, b power m, c power n, b power n, c power m, you will say that this is not context free, because you will try to compare these two and you will try to compare these two, right? So writing it is very important. Okay, if I write like this, it is very clear that I am going to compare a's and b's and I am going to compare b's and c's. And also you have to handle all the dead configurations. Okay, see, once you have done the PDA for the strings which are in the language, dead configurations will always fall in place. You don't have to worry about dead configurations. You take the strings in the language and construct the pushdown automata. Dead configurations will not be a problem. Okay. Okay. Very good. Who has answered these questions? Many people are able to answer these questions. Okay. Krutika, good. Siva, good. Manasa, good. Nitin, good. Pratibhanu, good. Okay. So, let me answer it. Okay. So, first we are going to compare A's and B's. So, what should I do? Initially, you push A's. This is a little bit tricky question. Just try to understand it. Okay. So, initially, A will be in the input. Z0 will be on top of the stack. So, you are going to push A. Right. And then A will be in the input, A will be on top of the stack, you are going to push A. So all the A's are pushed. Now whenever you see a B, go to a new state. See, don't do this in the same state, because after a B you will get a and you will accept it. That is why go to a new state, remembering that we have seen a B and we should not see a. Now if B is in the, if B is, see, what is the minimum string here? The minimum string is A, B, B, C. So when you see a B, there will definitely be a. When you see a B, there will be definitely be a. Okay. So when you see a B, there will definitely be a. Pop it. And then you may see any number of B's, keep popping A's. Okay. Now let us take an example and explain you. Let us say A, B, 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 C, C. Now you have pushed all A's, and for two B's you have popped all the A's. Now still B's will come. You have to push B's and you have to pop B's according to the C's. Now the question is, when should I start pushing B's? Here we are popping A's, right? When should we start pushing B's? When all the A's are over. So what does that mean? What does that mean? So see, one more thing. There is nothing called minimal pushdown automata. So it can be done in lesser number of states, but that we are not interested. There is nothing called minimization of pushdown automata. Okay, so I will use a different state. You can do in the same state also, but I don't want to confuse you, right? So if I get a B, and if the top of the stack is Z0, what does that mean? A's are all over. then I will start pushing B's. Then I will start pushing B's. Okay, why am I pushing B's? So that I can compare with C's later. Okay, now any number of B's may come. Let B is on top of the stack. Any number of B's may come. Let B is on top of the stack. I'm just going to push B's. Now finally what happens? Now finally what happens? Now once all the B's are over, you will keep getting C's. Once all the B's are over, you will keep getting C's. Now what will be on top of this stack when I get the first B? Definitely it will be B. The reason is the minimal string that we get is A, B, B, C, right? These two A's will be matched with B's and B's are pushed. Whenever I get a C, there will definitely be a B on the top of the stack, at least one B. Then pop of the B. Now there may be more C's coming up. So let all the C's come up. There may be more C's coming up. Let all the C's come up. Let all the C's come up. And I'm going to pop B's for every C. Okay. Now problem is not yet over. At the end, you should see epsilon, which means this string should be over, right? And there should be nothing on the stack, which means Z0. Leave it as Z0 or remove it, not a problem. Then you are going to accept it. This step is important. This step is important. Okay. Okay. Cool. Solve this question. What was the previous question? A power n, B power m, C power n plus m such that n comma m greater than or equal to 1. Such that m comma n greater than or equal to 1. Solve this. Try it. See, push down automata you are going to try. Okay. Push down automata you are going to try. Okay. See, I want you to try these problems. If I explain you will forget, definitely forget. Please try, okay? See, we have hell a lot of time. The entire day I'm going to take TOC, right? We have time. Solve it, please. Only 4 5 people are able to answer it. If you do like this, you will not get a top 100 rank, okay? Try, please, okay? With evening maybe Nandi podcast only. Hello, Pratna. Evening Nidhi Nadi podcast only. Requirement gathering questions on the prepare చేయి what exactly I need అనేది and you ask me the questions I can answer what problem we are trying to solve, okay? Huh? Hello, hello, ఏం చెప్పు వినపడలేదు కాల్ చేస్తాను. Try it, guys. Questions prepare చేయి what is the problem we are trying to solve and you will ask me questions and I will answer what I want, okay? అది టైం వచ్చేసి 5 o'clock పెట్టుకుందాం. 5 to 8 మేబీ 2 3 hours ఉంటుంది. లైక్ మెమరీ కార్డ్స్ అన్ని అరేంజ్ ఓకే. పెద్ద పెద్ద సెట్టింగ్ ఏం అవసరం లేదు, జస్ట్ ఎల్లో చైర్స్ పెట్టేసి కొట్టేస్తాం. షిఫ్ట్ అయిపోయింది మొబైల్. క్వశ్చన్స్ అన్ని ప్రిపేర్ చేయవా కొంచెం? అది హెయిర్ బ్యాండ్ పెట్టుకో, ఓకే? ఓకే సార్, బాయ్. So, how are you going to do this? Please try Piston Automata. Don't depend on me because these questions are difficult. If you depend on me, you are not going to, yeah. Thing is, very less people are answering. These are all important questions. Very good. So, who has answered it? Siva has answered it. Good. Pratibhanu has answered it. Good. Manasa. Manasa, what are those lines? Good, Manasa. Yusuf, very good. See, if only 4 or 5 people are answering it. Okay. So, how are you going to write this? See, once you write it properly, everything will be easy. So, a power n, b power m, you have to write it as c power m, c power n. If you write it like this, a power n, b power m, c power n, c power m, it is going to be a problem. You may try to compare A's and C's, between B's will come, you may try to compare B's and C's. So writing it is important, okay? Now n comma m greater than or equal to 1. Now what is the smallest string here? So m comma n greater than or equal to 1 means smallest string is A, B, C, C. So definitely the strings are going to start with A, and after a B you should not see a, and after a C you should not see a B, and after CC you should not see a B. Okay. Now what is the meaning of this question? The number of A's and B's should be equal to number of C's, and also they should follow the pattern A, B, C, C. Right. See, clearly this is a subset of A star, B star, C star. Clearly this is a subset of A star, B star, C star. And we have seen the complement also, right? So, in the regular languages. So, even though A star, B star, C star is a regular language, the subset of it is not regular. Okay. Even in the previous cases also you can do the same. See this, when I have A power n, B power m plus n, C power m, this is a subset of A star, B star, C star. This is a regular language. Subset of regular language need not be regular. It may or may not be regular. When will it be regular? If I write A star, it is regular. B star, it is regular. C star, it is regular, right? So subset of a regular language may or may not be regular. And also here also, A power n plus m, B power m, C power n is clearly a subset of A star, B star, C star. This is a regular language, but this is not a regular language because finite automata cannot compare, right? So let's see all the languages and let's say whether they are regular or not. Okay, let's see all the languages. Now A power n, B power n is not regular. It is DCFL and everything. Now similarly, A power n, B power n, C power n, it is definitely not regular, but this is DCFL and above. Now you don't know what is a DCFL, deterministic context free language. I'll explain that when the time comes. For now, remember that it is a DCFL. Okay. Now even this language is not regular, but it is DCFL and above. And here also, this is not regular, right? Because comparisons are involved, and it is DCFL, deterministic context free language. Now there is something called as deterministic pushdown automata. So what does that mean? A state upon seeing one configuration will go to only one state. Okay, I'll take an example and explain it. I don't want to confuse you much. Just go with the flow. You will not miss a single question on this. Okay. So A power n, B power m, C power m, C power n. So what do? Push all the A's, push all the A's and push all the B's, right? For every C, you pop B's, and for every C after that, you pop A's. So basically, if you look at it, we are pushing A's and B's, and then we are popping C's. So here I want to give you a different answer where we are trying to minimize the number of states in pushdown automata. But there is no need to minimize the number of states in pushdown automata in general. There is no need to minimize the number of states in pushdown automata in general. Okay, let's see this. So you are going to push A's and B's, right? So A on seeing a Z naught, I'm going to push A, and A on seeing a I'm going to push A, right? Now we have to push B's also. Now if you try to push B's here, so A will be on top of the A, B A. If I write like this, the problem is A's may come, then B's may come, then A's may come. Right? But then the configurations are different. See, initially if I get, this is initial configuration, right? Initially if I get a, I'm going to accept A. I'm going to push A. And if top of the stack is A, I'm going to push A, right? Now when I get a B, if the top of the stack is A, it means it is not the initial condition, it is in the middle. I will push B onto the top of the stack. Now, if I get B, and if top of the stack is B, I will keep pushing BB. I can do this. The reason is configurations are different. Even though here there is B, here there is B, here there is A will be pushed only in the initial state and only when A are on the top of the stack. B will be pushed only when A is on the top of the stack or B is on the top of the stack. See, if you have a string A, B, A, it will not be, it will go to dead configuration. The reason is you are going to push, let us say this, A, B, A, right? Now, let us say this is Q naught, Q naught. When you are in Q naught, okay, if you see a, when you are in Q naught, if you see a, you will go to Q naught only, and on the stack, A will be pushed on the stack, A will be pushed, right, right. Now if I see a B, what is the minimum string here? Minimum string is, okay, let's do this string. Now if I see a B in Q naught and A is on top of the stack, it means it is the first B and I'm going to push that B right here. It is the first B, I'm going to push that B. Now I'll be on Q naught. Now what will be the configuration for Q naught? A is the input and top of the stack is B. It is not defined, right? A and top of the stack is B is not defined. Therefore, the dead configuration will automatically handle the cases where A comes after a B. So, see, I'm trying to complicate it. You have done enough examples that you should be able to understand this. I'm trying to do a pushdown automata with least number of states. Your answer is right. You can have any number of states in pushdown automata, but I'm trying to teach you something new, okay, with this example. Now what happens? Now C's will come. Now C's will come. Now when C's come, definitely B. See, what is the minimum string here, guys? A, B, C, C. The minimum string is A, B, C, C. The minimum string is A, B, C, C. Right. So, when I get the first C, definitely B will be on top of the stack. Pop it off. Okay. Now, if I get a C, B will be on top of the stack. Pop it off. Pop it off. Now, when all the B's are over, then you will keep getting A's. Now, the question is, why are we doing it in the same state? The reason is, while pushing the strings, I made sure that A's are pushed first and then B's. That is why I am popping off B's first and then I can pop off A's because they are ordered. While pushing, they are ordered. So while popping, you don't have to think about order. You don't have to go to a different state. Now, finally, the input is over. Now, finally, the input is over. Okay. Now, what will be on the top of the stack? Z naught. Leave it as Z naught and you accept it. So, 3 states are sufficient to solve this problem. But don't worry about constructing a minimal push down automata. I just showed you as an example that you can do like this, but you don't have to follow this. There is nothing called minimization of push down automata. PDA ka minimization, there is nothing. Okay. So what you had done is, A's you are pushing here, B's you are pushing in the next state, and then B's you are popping in the next state, and A's you are popping in the next state, and finally you are going to put this. That is not required. Okay. It comes with practice. Now, if you ask me, how do I know? How did I do? It comes with practice. It comes with practice. Okay. Hmm. Everyone got it? So, 3 states are sufficient. Some people are doing it with 5 states. That's okay. You are right. Even if you go for 5 states or 4 states, that's okay. 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 Now answer this question. A power n, b power 2n such that n greater than or equal to 1. A power n, b power 2n such that n greater than or equal to 1. See, for this question, there are two ways to answer it, and I want you to answer in both the ways. Very good. Not everyone has given two ways. There will be two ways to answer this. Okay. There will be two ways to answer this. Try it, everyone. Try this. Try this, everyone. There will be two ways of answer. Okay. I have intentionally added 5 options to confuse you. Okay. There were only 4 options. I have added 5 options just to confuse you. Okay. I have intentionally added 5 options. Okay, I will do both the methods. Okay. I will do both the methods. Okay. So, guys, there are two ways to solve it. So, one way is, see, one way of solving it is, for every A, you push 2 A's, and for every B, you pop 1 A. See, what is this question? A's, B's should always follow A's, B's should always follow A's, and number of A's should be equal to 2 times the number of B's. Number of A's should be equal to 2 times. So you can write it like this, right? A power n, B power m, such that m equal to 2n. M equal to 2n. Now, is it regular? You can try it. What is the complement of this, guys? The complement of it is a power n, b power m, such that m is not equal to 2n, union. What are the strings that are not there in the language? BA. A plus B star, BA a plus b star, right? And this part is definitely regular, but here comparison is used. This is not regular, right? Anyway, directly you can say comparisons are used, that is why it is not regular. Union of a non-regular and regular may be regular, may not be regular. Can you tell me union of non-regular and regular which is regular? So if I have a power n, b power n such that n is greater than or equal to 1, if I union it with a plus b whole star, so this is regular. This is regular, right? And this is non-regular, but the union is regular. Okay, anyway, this is all about regular languages. Let's focus here. Okay, so initially when you get a you push two a's. Initially when you get a you push two a's. Initially if you get a you push two a's. You push two a's. Initially when you get a you push two a's. Now whenever you get a b, you pop a. Okay, you pop a. Whenever you get a b, you pop a. You have to go to a different state, otherwise after b, c may come, right? And finally what happens? Epsilon is at the end of the string. Epsilon is the end of the string and a's are over. So z naught, leave it as z naught and you accept it. Leave it as z naught and you accept it. This is one way. What is the other way? For every a you push a, right? If there is a and z naught on top of the stack, you are going to push a, and for any extra a's, I mean the second a's onwards, you are going to push a. So for every a you are going to push a. Now what happens? B's are double. So what you can do is for the first b when you see it, let a be on top of the stack, leave a as it is, don't push or don't pop. Now when you get the second a, second b, small a is on top of the stack, you just pop it, right? And you can keep repeating it. Right? So if I take a b, first b, see, first b, no pop, second b, pop, third b, no pop, fourth b, pop. Now finally yes will be over and string will be over. Epsilon z naught, leave it as z naught or you can delete it, not a problem, then you accept it. So these two are definitely one and the same. Okay, one and the same. Now answer this. A power n, b power 2n plus 1 such that n is greater than or equal to 1. A power n, b power 2n plus 1 such that n is greater than or equal to 1. N is greater than or equal to 1. Very good. Two people have answered it. See, it is just an extension to the previous question. It is just an extension to the previous question, right? See, you should know how to write it. You can write it like this: a power n, b power 2n followed by a b. Then it is previous question. So, if you see a z0 is on top of this tag, push a. If you see a z0 is on top of this tag, push a. And if you see a is on top of this tag, push a, push a. Right. Now, for the first B, when you see a don't do anything. And for the second B, when you see a pop a. For every two B's, one A is getting popped. For the third B, A is on top of the stack. Leave it as A. Now, once everything is done, once everything is done, string last B should remain. Right? So, there should be a B and all A's should be over. Z0, leave it as Z0, right? And then now the question is, you will accept it here, right? Don't accept it here. The reason is, I may have A, B, 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 B. You are checking till this part and you are accepting it. What if a comes? You have to make sure that there is no A after it, right? So let the entire string get over. Let the entire string get over and Z0 be on the top of the stack. Leave it as Z0 and you accept it. Okay. So you have to do this. This part is important. Now what is the other way of doing it? The other way of doing it is, for every A, you push two A's. For every A, sorry. For every A, Z0 is on top of the stack, you push two A's, right? And for every A is on top of the stack, you push two A's. You push two A's. Okay. Now, for every B, when you see a pop off A. Keep doing this. For every B, if you see a pop off A. Now, finally, what happens? One B will be remaining. So, if you get one B, top of the stack is Z0. Don't do anything. Just leave it as it is. Now, after that, check that after the final B, there is nothing. Okay. So, epsilon Z0, leave it as Z0 and you accept it. The common mistake that you do is you will accept it here. Then what happens? After a B, a may come, but you are still ending up in the final state. Right? Right. Do this. A power n, B power m, such that, acha, what about the language that I forgot to tell you? So this comparison is required, right? This is definitely not regular. But this language, a power n, b power 2n plus 1, is a subset of a star, b star. right? In fact, A star B star is a subset of A plus B whole star. So, a subset of regular language need not be regular. A subset of regular language need not be regular. A subset of regular language need not be regular. Solve for this. A power n, B power n such that n is greater than m. Number of A's should be greater than number of B's. Number of A's should be greater than Divya. They will just ask. See, they are not going to ask you to construct the pushdown automata. The questions will be whether a language is context-free language or not, deterministic context-free language or not. Don't worry, we will solve all the PYQs, okay? So next Sunday we will have a marathon where we will solve all the PYQs of finite automata. Okay. Solve this. Number of A's should be greater than number of B's. It's okay. You can take time. See, we are doing these questions for the first time, right? You can take time. That's okay. Okay. Very good. Now all of you are able to answer it, okay? Now all of these are you can answer. I mean everyone is answering right actually. So now I think you got a hold of push down automata. Okay? Try it guys. Only few people have answered. Yeah, your answers are right. Little bit mistake is there, but that's okay. See, when you are solving it for the first time, I'll excuse you. I will not say anything, okay? Please answer it. Even if you are wrong, I will correct you, okay? Even if it is wrong, I will correct you, okay? Okay, so A's should be greater than B's. See, what is this? See, what is this language? A power n, B power n such that A should be greater than B's. In fact, this A power n, B power m is a subset of A star B star, which is a subset of A plus B whole star, right? But still this language is not regular. Why? Because comparison is involved. Finite automata cannot do comparison. I have given you RBR rules 2A, 2B, 2C, 2D when the language is infinite, and in 2C I told you that comparisons finite automata cannot do. Okay? Yeah. So what you do, push all A's first, okay? See, definitely here the thing is A's and B's are not given. Let us assume that n comma m greater than or equal to 1, right? So there should be at least one B. What is the smallest string in this? AAB. Smallest string is AAB. There should at least be one B. Smallest string is AAB. Right. So initially you will get yes. Okay, push yes, and any number of yes may come. Keep pushing all yes. Keep pushing all yes. Now, once a B comes, A is on top of the stack, right? Once a B comes, A is on top of the stack, right? Now, once a B comes, A is on top of the stack. You are going to pop, and any number of B's may come. A will be on top of the stack. You are going to pop. Finally, all the B's should be over. But on top of this stack, at least one A should remain. Then leave it as it is or pop it off. No problem. Then you are going to accept it. Now, what does this mean? We are pushing A's. We are popping A's for B's. Now, after that, once the entire string is over, after that, once the entire string is over, you are having extra A's. Once the entire string is over, you are having extra A's. You are having extra A's. Right? 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 Okay. Now answer next question. A power n, b power m such that n is less than m. A power m, b power m such that n is less than m. N is less than m. Take time and solve it, okay? I don't want speed, I want accuracy, okay? take time. We have lot of time. Okay. Okay. Most of you are able to solve it. And thing is that not everyone is solving it. See, if you want rank, please try it. Okay. Sir, what is the difference between epsilon and Z naught on final transition? Difference. Epsilon is in the input and Z naught is on top of the stack, right? Mansa. Okay. So, A power n, B power m such that n is less than m. So, number of A's should be less than number of B's. Okay. So, see, what is n comma m greater than or equal to 1, right? What is the smallest string you get? A has to be 1 and B has to be 2 B's. And again, this language, A power n, B power m, is a subset of A star, B star only, right? But here, any number of A's, any number of B's are allowed, but here, number of A's should be strictly less than number of B's. Number of A's should be strictly less than number of B's. Okay. So, what do I mean by that? By the time I complete all the B's, there should be no A's. Okay, let me draw it, you'll understand it. Okay, so initially when a comes, Z naught is on top of the stack, you are going to push A's. Any number of A's we are going to push. Any number of A's you are going to push. Right, right. Now when a B comes, see this, when a B comes, definitely there will be one A, pop it off. Now, for every B, pop off A. For every B, you pop off A. Okay. Then what happens? B's will remain, right? So B's will remain and top of the stack will be Z0, which means A's are over. Leave it as Z0, leave it as Z0 and let any number of B's come. Just leave it as Z0, right? And finally, when what should remain? B should remain, right? So any number of B's. So finally, we are not doing anything with B's, right? So finally, this string should end. This string should end. And there should be Z0 on top of the stack. Leave it as Z0 and you accept it, right? Now the question is, can I do this in this state is the question. Yes, we can do it in this state. One more DFA, push down automate I am giving you is, let any number of A's come, just keep pushing A's and let any number of A's come, just keep pushing A's. Now when a B comes, you keep popping A's and finally any number of B's may come, keep popping A's. Now all the A's will be over. So B on Z0, keep Z0 as it is. Okay. Now any number of B's may come. Z0 will be on top of the stack. So just leave it as Z0. Just leave it as Z0. Just leave it as Z0. Right. Finally, what should happen? Entire string should be over. Okay. Finally, what should happen? Oh, we cannot do it like this. If I do it like this, equal number of A's and B's are also getting accepted. No. So let all the A's be over. Then there will be B's remaining. Let all B's be over. Then there will be epsilon in the end of the string. Z0 and then this. This step is important. Why? Because we have to be sure that after B's there are no A's. That is why. Okay. So this solution is definitely possible. This solution is definitely possible. Right? Right? Okay. Now let's do the next question. Okay. Fine. So do for this WCWR, right? So W belong to A plus B plus and WR is reversal of W. WR is reversal of W. WR is reversal of W. Okay. So this is a palindrome with a center. This is a palindrome with a center, right? So see this. Let us say W equal to ABA. Then what will be WC? WR, C is the center. See, in exam, gate exam, they have given this. W hash WR. It is same as knowing the center, okay? So, ABA followed by C followed by ABA. No, this is a wrong example. Let me take a different example. Now, let us say W equal to ABB. Now, what do I get? ABB followed by C followed by B, B, A. Now what should you do? Till you get a center, you push. Then you match this B with this B, this B with this B, this A with this A. Now try it. Now try it. Wow, Kirutika, fantastic Kirutika, and Pratibhanu, fantastic Pratibhanu, and Divya, very good Divya, very good. Okay, so let me explain it. Okay, see, see, you have to analyze with strings. Okay, W can be anything. So initially A may come, then B, and then so on. Or initially B may come and then A, so on. Or A may come and then A, so on. Or B may come and then B, so on. Right? Or initially, so we have to handle all these cases. We have to handle all these cases. Right? So initially, A may come, Z0 is on top of the stack, we are going to push A. B may come, Z0 is on top of the stack, we have to push B. Now, A may come and top of the stack can be A, then you have to push A. And A may come, top of the stack may be B, you have to push B. Similarly, B may come, top of the stack can be B, you have to push B. Similarly, B may come, top of the stack is A, you have to push B, right? So you'll get all these cases. For W, all these cases are possible. A, B, B, A, B, B. And initially A can come or B can come, right? Now let us say we have seen the center. When you have seen the center, top of the stack can be A or top of the stack can be B. Don't do anything, just leave A or B as it is. Now we are going to the matching state, right? Now what should we match? B with B, B with B, A with B. So whenever there is a match, A is in the input and A is on top of the stack, okay, pop it off. Similarly, when B is in the input, B is on top of the stack, pop it off. Pop it off. Pop it off. Okay. Okay. Now after that, the entire string should be over and we should get Z0. Leave it as Z0 and accept it. Many people have answered it right. Many people have answered it right. Okay. Strings are W such that number of A's in W is equal to number of B's in W. Number of A's in W is equal to number of B's in W. Somewhat tricky question. So this language is not equal to A power n, B power n such that n is greater than or equal to 1. If you call this language as L1, L1 is a superset of A power n, B power n such that n is greater than or equal to 1. Why? Because we may get strings like this: A, B, A, B, equal number of A's and B's, A, B, B, A, equal number of A's and B's, B, B, A, A, equal number of A's and B's, equal number of A's and B's. Try it everyone, try it.
इन लोगों को सिखा देंगे। ठीक है, बाय।
Wow, wow. Kirutika is killing it. Pratibhanu, very good. Pratibhanu, that was a previous question, right? Manasa, small mistake, but Kirutika, very good. Try it, guys. It is not very difficult, right? Kirutika, you nailed it. इंस्टाग्राम में होगा किसी फोटो, देख लेना एक बार।
हाँ हाँ ठीक है हाँ हाँ चल हाँ हाँ हाँ
अच्छा सुनो, अभी आई एम एंडिंग द क्लास इन मे बी 5-10 minutes. या हाँ या so I am ending the class in 5-10 minutes. Now schedule the next class at 1:30. Okay.
okay so what is the name of class?
Context-free languages part 2.
130 को तो ऑलरेडी है ना, कर दिया है, पर पार्ट 2 ऑलरेडी। अच्छा ये वाला कौन सा था? आई चेक द नेम।
This is part 1.
हाँ तो पार्ट 2 ऑलरेडी कर दिया है 130 का।
ठीक है, okay fine.
सुबह का था ना, सुबह का कॉन्टेक्स्ट फ्री लैंग्वेज पार्ट 1 था ना।
And please align Jnana. Okay. Jnana.
When you tell me, because I don't know his surname also to search on Insta. Okay, why he is not giving pic? Let me talk to him and then we have to tell to Manu accordingly. So I'll just call Mubin if you want.
Yeah. I think he's at home.
अच्छा ठीक है चलेगा।
Okay.
You call me once you're done.
Okay. Yeah.
You call me.
Okay. Cool. Bye. Next class is at 1:30. Okay. We'll have lunch break and then we'll continue. So see guys, in order to solve this, you should understand one thing. See, whenever BB is there, we will push A and we will push A, and for this B we will pop this A, and for this B we will pop this A. Now if I have AB, okay, we will push A, and for this B we will pop A, and for this B we will pop A, right? Now whenever there is AB, let us say A, B, push A. Whenever there is a chance to pop B, you pop it. Okay, whenever there is a chance to pop B, you pop it. Or if I have B, A, push B, we cannot pop B, so push B. We cannot pop B, so push B, right? So whenever there is a chance of popping, chance पे dance करना. Okay, whenever you get a chance to pop, you can pop. Whenever you have a chance to pop, you can pop, right? So what happens is, whenever there is a chance to pop, you pop. Whenever there is no chance to pop, you push. That is the logic. Okay. Can you do it now? I have given you the logic. Can you try it now? Very good. Many people have answered it. Okay. Yeah. So little bit wrong, but then that's okay. You tried. I'm very happy that you tried. Okay. So initially, A may come, Z0 will be on top of the stack. You add, you push A. B may come, Z0 is on top of the stack. You push B. Right. Now A may come, A is on top of the stack. We don't have any option other than pushing it. Okay. And B may come, B may be on top of the stack. We can't pop, right? But then if A comes and B is on top of the stack, you can pop B. Similarly, if a B comes, A is on top of the stack, you can pop A. So whenever you have a chance to pop, you pop. Whenever you don't have chance to pop, you push. Simple, right? Finally, what should happen? The entire string should be over. Finally, the entire string should be over and stack should be empty. Leave it as it is, or you can pop off Z0, not a problem. Then you accept it, right? This is how you handle. So till now, whatever I have discussed, all these problems, till now we have discussed many problems in push down automata. All these problems come under a category called deterministic push down automata, DPDA. All these problems will come under the category called deterministic push down automata, DPDA. Now, why are they deterministic? Because in all these examples, we know exactly when to push and when to pop. Sometimes what happens is we don't know whether to push or pop or what action to take. Then we will take multiple routes just like NFA. Now that machine is called non-deterministic push down automata, right? So you know what? In case of NFA, DFA has same power as NFA, right? But in case of push down automata, deterministic push down automata is less powerful than non-deterministic push down automata. Deterministic push down automata is less powerful than non-deterministic push down automata. Non-deterministic push down automata. Okay. So with this, we have completed deterministic push down automata. Okay. Now the next thing is we will start with non-deterministic push down automata. Okay. Non-deterministic push down automata. At 1:30 we will start the class. Okay. At 1:30 we will start the class. Gnana. Hello. Class end cheyana and next class 1:30 ke. Next class 1:30 okay. Hello.